So usually we're used to the notion of taking the derivative of a function that looks something like this. F of x is equal to something with x, right? And it's already solved for f of x. Or you can think of it as y is equal to something. Now, what if we had a function where it wasn't directly solved for x? So let's say we had yx is equal to 1. So how can we take the derivative of something like this? Well, in this case, we can simply we can divide by x to solve for y on both sides. So this comes out to be y is equal to 1 over x. And then we know that this is just x to the negative 1, and we can use our power rule and take the derivative. So y prime is just equal to negative x to the negative 2. Now, if you don't know what I did there, I encourage you to watch the power rule video. Now, let's do this another way, which is called implicit differentiation. And at first you might not appreciate the power of this, but this will help us take the derivatives of functions that can't directly be solved for y and other functions as well. So let's do this a different way, and then we're going to do another example right after this that you actually cannot solve for y. So let's do it right here. So we have yx again is equal to 1. What we're going to do this time is we're actually just going to take the derivative with respect to x of both sides. So dx of the left, and then dx of the right. Okay, so the right is easy, so derivative of a constant is just 0, so that's good. So we get 0 here. Now for the left side, we have to do product rule, because we have two functions being multiplied together, right? And one of the functions is actually in terms of x, right? It's a function of x. So that means we have to do chain rule in that case. So first, let's do the derivative of y times x. So that's just going to be a y prime and then x, right? And then plus derivative of x. Derivative of x with respect to x, that's just 1, and then times y. So 1 times y is just y. And again, if you didn't know what I did there, I encourage you to watch the product rule video. That will help with implicit differentiation. So now what we can do is we can actually just solve for y prime, because we're looking for y prime, right? That's the derivative of the function. So we can just solve for it in this equation that we have, and we'll get our answer. So let's solve for it. We're just going to get it alone. Subtract y on both sides. We get y prime x is equal to negative y. Divide both sides by x. We get y prime is equal to negative y over x. Now in some cases you can leave it like this, but in this case we know what y is. We can solve for it in terms of x, right? And it's better if you have the derivative in terms of just x, not the function itself. So let's just plug that in. So we get y prime is equal to, well, negative y is just negative 1 over x, right? Because this is y. So negative 1 over x divided by x. And this is just equal to negative 1 over x squared, which we can rewrite as negative x to the negative 2. And that's actually the same exact thing that we got there. So that's good. Now let's do an example where we actually have to use implicit differentiation. So that example will be x squared plus y squared is equal to 1. Now in this case, y is still solvable for, but we actually get two functions for y, right? This isn't really a function anymore. This is just a relation. And that's where implicit differentiation comes in handy, where we have just relationships between variables, and we want to find a derivative of one of the variables in terms of the other. So what we're going to do again is we're going to take the derivative of both the left and the right. So let me write the 1 a little bit more this way. All right, so we have dx of the whole thing, and then the dx of 1. So we can take the derivative of each term, right? Derivative of x squared with respect to x, that's just going to be 2x. Let's see. And then the derivative of y squared, well, with respect to x, that will be 2y, and then chain rule, right? Because it's in terms of x, so times y prime, and this is equal to 0. Now again, what we can do is we can actually just solve for y prime. So we get 2y y prime is equal to negative 2x. Divide both sides by 2, get rid of that, and then divided by y. So we get y prime is equal to negative 2x over y. And in this case, we can just leave our answer in terms of y. So we have a derivative of our function, or of our relation, in terms of y. And there's sort of the reason why we leave it in terms of y is because it depends on which y value you use. Because if you solve for y, you can get 1. So yeah, let's actually do that. So if we have x squared plus y squared is equal to 1, we can solve for y, but we get 2 values, right? So we can subtract x squared on both sides, take the square root, we get plus or minus the square root of 1 minus x squared. So now it's up to you whether you want to use, so I'm going on a tangent here, but y squared plus x squared equals 1 is a circle, right? So if you want the derivative function to give you the tangent lines of this portion of the circle or this portion of the circle. So that's up to you. You either plug in the positive square root of 1 minus x squared or the negative. And the reason why we do that is because we can't take the derivative of a relation, but we can take derivatives of functions. But we could take the derivative of relations if we leave it in terms of the function itself. And that might sound confusing, but essentially what I'm saying is when we take the derivative, we need to essentially act like the top is just a parabola and we take the derivative of that part. Or we just take the derivative of the bottom. So right here, y is a variable, and we decide whether we want to plug in the positive square root or the negative. All right, talk to you guys in the next video.